Okay, so this video is about fractions and the rules of exponents, and more specifically we're going to look at fractions with negative exponents. Now, there are several types. I can have negative exponents mixed within a fraction, which you guys have already done, but this is a fraction, something in here, with a negative exponent on the outside. We're going to talk about how to figure that out. Okay, so really, everything we've done so far, you're going to continue to do. We use the rules in the ways that we have been. Negative exponents move between the numerator and the denominator to make an exponent positive, depending on where it's at. You add exponents if you're multiplying. If you're dividing, you're going to cancel out anything over itself, making it into a 1. And then if it's a power to a power, this one's important. Power to a power, you write your fraction or whatever you have, however many times it's indicated, and then multiply them, back up here to the adding, them together. So that one is going to show up for sure. Really, like I said, what we're focusing on is a fraction that has a negative exponent outside. The fix to it is really easy. What we do is we flip the whole fraction to make it a positive exponent. And it's a great idea to simplify first inside your fraction. That just makes everything easier to deal with. So, this is our problem. I have 5x cubed y squared over x to the 8th y in parentheses to the negative third. This, negative 3, is the negative exponent that we're talking about here. The first thing we want to do is simplify everything inside. So, I'm going to write it all out. Over 1, 2, 3, 4, 5, 6, 7, 8, and then 1y. And we reduce anything that is over itself. So those y's will cancel, and 3 of those x's are going to cancel. So what I'm left with is 5y over 1, 2, 3, 4, 5 x's, x to the 5th. And all of that is to the negative third. Now, the rule that we're talking about here is that we flip the fraction and give it a positive exponent. Okay, and that's it. It's all we have to do. It's positive exponent now, but you do have to flip the whole fraction, and nothing else changes in that fraction. Now that 3 here means that we multiply this out, or we write this out 3 times. So I'm going to have x to the 5th, and then over 5y, x to the 5th over 5y, x to the 5th over 5y. And now we're multiplying, so we add our exponents. Well, 5 plus 5 plus 5 is 15. Y to the first, y to the first, y to the first, that's really y cubed, because 1 plus 1 plus 1 is 3. And I multiply those coefficients, the 5s. Well, 5 times 5 is 25 times another 5 is 125. And there is my answer. Okay? Okay, so we have 2 more examples to go through here. And feel free, if you want to pause this and try it on your own and then come back and check it, that is fine. I'm going to work through them both on the screen here. My work might get a little sloppy, so I'm going to try to keep it nice and organized, but feel free to try them on your own if you want. Okay, we're going to start with the first one here. Okay, 2a to the 4th b cubed c to the 9th over 4a c to the 10th, all in parentheses to the negative second. First thing I want to do is simplify what's inside. So I'm going to write it all out. I have a 2, 1, 2, 3, 4 a's, 1, 2, 3 b's, 1, 2, 3, 4, 5, 6, 7, 8, 9 c's over a 4, 1a, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 c's. And we cancel anything over itself. So 1, 2, 3, 4, 5, 6, 7, 8, 9 c's cancel, and then 1a will cancel. And remember that I do divide those coefficients. Well, 2 over 4 is really 1 over 2. Now I have a cubed left. The b cubed didn't change at all. Then I have 1c left in the denominator. Now that is my fraction. to the negative second. My rule that we're focusing on today is that we flip the whole thing and make the outer exponent positive. Okay? Now this 1 here, I don't need to write it. You can leave it, but it's not necessary. All right? And then this 2 on the outside as the exponent means that I have 2 of this group. So I have 2ca cubed b cubed, 2ca cubed b cubed, and I multiply these together. 2 times 2 is 4. cc is c squared. A cubed, a to the 6th, b cubed, b to the 6th. There's my answer. That easy. Okay? Next one over here. Same idea. So I have 10. I'm going to write it all out and simplify the inside part first. X to the 7th, 7 x's, and 2 z's over 5 with 2 x's, 4, 5, 6, 7, 8 z's. We cancel anything over itself. X's cancel, and then 2 of those z's cancel. So I forgot about these. I divide these. 10 over 5 is really 2 over 1. Now, I am going to write that 1. I know on the last one I told you it wasn't necessary, but that's after I had already flipped it. I'm going to go ahead and put it because my negative exponent, I still have to flip this fraction, and I want to have that 1 up top. So 2 over 1, I have 1, 2, 3, 4, 5 x's in the numerator still, and 1, 2, 3, 4, 5, 6 z's in the denominator. All of that to the negative third. Now I flip the whole thing. So 1 z to the 6th over 2x to the 5th, in parentheses to the positive 3 exponent. And that 3 exponent means that I have 3 groups of this, so I'm going to write 1 z to the 6th over 2x to the 5th times 1 z to the 6th over 2x to the 5th times 1 z to the 6th over 2x to the 5th. And then I'm going to multiply. 1 times 1 times 1 is 1, and then I add these exponents. 6 plus 6 plus 6 is 18 over, multiply the 2 and the 2, that gives me 8. Add those exponents of 5. Well, 5 plus 5 plus 5 is 15. And there's my answer. Okay, so again, we're not doing anything really different. Everything that we have learned so far is the same. The rules are still applying. The only new idea here is to get rid of a negative exponent on the outside of a fraction. You have to flip the whole fraction, and it makes that exponent on the outside positive. Nothing changes except the outside exponent. Everything inside stays the same. Now, helpful hint is to simplify inside the parentheses first. You do not have to do it. It just makes your problem a lot longer if you don't. For example, on the last ones here where we had an exponent of 2, a negative 2, and a negative 3, if I didn't simplify those first, then I would be writing that whole fraction, all of it out in expanded form 2 and 3 times. If I simplify it, I'm really writing it out expanded once, and then flipping it and writing it out multiple times. But then I can use my rules and I don't have to cancel anything because everything would have already canceled when I simplified it the first time. So it's not necessary that you simplify it first, but I'm going to tell you it is 10 times easier if you do. It saves you a bunch of work. Okay, so you have a short Schoology assignment following the same format we've been doing. Short Schoology assignment on this. If you have questions, please email me or post them in the discussion board. Good luck.